Good afternoon. Today I'd like to talk about the introduction of the Cartesian coordinate system and the impact it had on the concept of a function. And so it all began with René Descartes, French mathematician in the 1600s, when he took two number lines and the horizontal one he called the x-axis, and the vertical one he called the y-axis. These are just two number lines. They intersect at a special point called the origin 0, 0. To the right of the origin are the positive numbers. To the left are the negative numbers. Same thing for the y-axis. It's just a number line. Going up from the origin are the positive numbers, and below are the negative numbers. And what this allows us to do is to plot some points. You will recognize, first of all, that the x and y axis partition the plane into four quadrants. The first quadrant is in the upper right, and then we go counterclockwise to arrive at the second quadrant, followed by the third, and followed by the fourth quadrant. With these four quadrants, we can place any arrangement of two values, one value for the x-axis, one value for the y-axis. The numbers come in numerical order, x first and y second. So a point labeled 4, 2 would go 4 units to the right and 2 units up, arriving at the point 4, 2. 4 units on the x-axis and 2 units on the y-axis. In the first quadrant, you will notice that all the points are positive. The x-coordinates are positive and the y-coordinates are positive. In the second quadrant, as you move to the left, you encounter negative values for x and positive values for y. In the third quadrant, both the x and y values will both be negative. And arriving at points in the fourth quadrant, the x coordinates will be all positive and the y coordinates will be negative. In the quiz that follows, you will practice locating points on the Cartesian coordinate plane. Now I'd like to talk about the impact that the Cartesian coordinate plane had on the concept of function. Well, first of all, function is a concept that has the following definition. A function consists of two sets domain and range. The domain is a set of x values. Range is a set of y values. And a rule that assigns to every value of x one and only one value of y. The Cartesian coordinate plane now allows us to identify very easily when a function, when an expression is a function graphically. For example, the equation y equals x is the equation of a line. When graphed on the xy axis, it has that graphical interpretation. And now to identify whether this is a function, we also take into consideration a special test called the vertical line test. Which simply says if I draw any vertical lines anywhere on the graph, if it touches one and only one point, then it passes the vertical line test. So the function y equals x passes the vertical line test because any vertical line that is drawn connects to one and only one point. Another function, y equals x squared, has the following look. And again, you can see that anywhere you draw vertical lines, it passes the vertical line test. There are some expressions, for example, x squared plus y squared equals 4, which gets interpreted as the equation of a circle with the center at the origin 0, 0, and a radius of 2. And you'll notice very quickly that this fails the vertical line test because it touches more than one point on any vertical line. That fails the actual definition, which means for one value of x, there are actually two distinct values of y. So if I pick x equals 1, there's a y value above that's positive, and there's a y value below that's negative. And so there are two different y values for one value of x.